Dear students, today we are going to the part 2 of machine learning course. Here we mainly discuss the topic how do machines learn. So before moving to the steps in learning process, we first see the definition for machine learning. Here we are having a definition, and this definition is stated by Tom H. Mitchell, a computer scientist who framed the formal definition for machine learning. And in his particular book, Introduction to Machine Learning, Mitchell states that a machine learns whenever it is able to utilize its own experience such that its performance improves on similar experiences in the future. So a machine learns whenever it is able to utilize its own experience such that its performance improves on similar experiences in the future. So here the learning process is similar as that of humans. The idea is that the machine should learn from its past experiences, and using this experience he will try to improve the corresponding output in the future prediction. How machines learn? Machines should learn similar as that of human learning. This learning is similar as that of humans. Human brains are naturally capable of learning from birth, but the conditions necessary for computers to learn must be made explicit. So all the human beings are having a tendency to learn from his experiences. So the same thing is applicable for computers, but we have to make the conditions explicitly for the computers. Now we see what are the different components or what are the different stages in machine learning. How do machines learn? Whether the learner is a machine or a human being, the basic learning process is similar. We can divide the learning process into 4 different stages. The first one is data storage, then comes the abstraction stage, after that generalization is there, and finally evaluation. Steps in the learning process. This is the diagrammatic representation of the various steps in the learning processes. The first step is data storage. So we are having a database for storing the data. Then from the data, we have to abstract some concepts. Then the third stage is generalization. From the concept, we have to make some conclusions about the concepts, that is the generalization stage. And finally, an evaluation stage is there, which is actually a feedback mechanism to measure the utility of learned knowledge, and it will be useful for further improvements. So the learning process should involve 4 steps: data storage, abstraction, generalization, and evaluation. Now we will see the different steps in detail. The first step is data storage. So in data storage, what happens is it utilizes the observation, memory, and recall to provide a factual basis for further reasoning. So all the learning must begin with some data, and in human being, the learning should start from the human brain. So in case of computer machines, computer uses its hard disk drives, flash memory, and random access memory for doing the learning procedure. So in learning process, the data storage is the first step. So in the data storage, it identifies, or it observation is the first thing. So it identifies the data, and this data must be stored in the corresponding memory. In human, it should be in the brain, or in computers, it should be in any storage devices like hard disk drive or flash memory or random access memory, something like that. The next stage is abstraction. So we already have some data in our data storage. The second process in the learning scenario is abstraction. So involves the translation of stored data into broader representation and concepts. So we are having some data in our data storage. In this second step, we are trying to make some representations from the stored data, or we are trying to derive some concepts from the stored data, that is giving some meaning towards the data. Or what we have to do is we have to do a data processing, and we have to convert the raw data to some meaningful information. Assigning meaning to stored data occurs during this particular stage, and it is the basis of knowledge representation. The formation of logical structures helps in turning raw sensory information into meaningful insight. So in this stage, a small way of data processing is happen. The raw data should be converted to somewhat a meaningful information. During knowledge representation, the computer summarizes the stored raw data using a model and explicit description of the patterns within the data. So here we have to convert the raw data in the format of a particular concept, or in the format of an information. For converting data to some information, we can make use of many different types of models like mathematical equations, relational diagrams such as trees or graphs. We can represent the data in the format of trees or graphs, etc. Or we can convert it into the format of a logical construct like if-else rules, or we can group of data known as clusters. And this process of fitting a model to a data set is known as the training the data, and data is transformed into an abstract form that summarizes the original information. So in this step 1, we observe the data and we store the data in our memory, and in the second stage, this raw data should be converted to some meaningful information, and this meaningful information can be represented in the format of a particular diagram, or it can be in the format of an equation. Likewise, a transformation of raw data to information should be happened in the second stage. Now we move on to the third stage. The third step in the learning process is generalization. So far we are having some abstract data in our hand or in the machine. In the third stage, it uses the abstracted data to create knowledge and inferences that drive action in new contexts. So here what happens is we are having some abstracted data with us. Using that abstracted data, we are trying to create knowledge, as well as we are trying to make inferences, or we are trying to make some conclusions about the data. So in generalization, it is a process of turning abstracted knowledge into a form that can be utilized for future action, and this concluded format or inferences can be used for future action on tasks that are similar but not identical to those it has seen before. So this generalized thing can be used for future applications which are similar as that of previous but not exactly same. It is imagined as a search through the entire set of models that could be abstracted during training. So generalization involves the reduction of this set into a manageable number of important findings, that is limiting the patterns it discovers to only those that will be most relevant to its future task. So the abstracted knowledge, from the abstracted knowledge, we are trying to make some conclusions, and using these conclusion statements, we can handle future situations. And in generally, it is not feasible to reduce the number of patterns by examining one by one and ranking them for future utility. So machine learning algorithms generally employ shortcuts and reduce the search space more quickly. And towards the end of the algorithm, we employ some heuristic technique which is designed for solving a problem more quickly. So in the machine learning scenario, the idea is that we are having a large data set, and from the data set we abstract some ideas, and the third stage what we have to do is from the abstracted data we will produce some conclusions. We are having a large number of conclusions from our stored data, but it is not easy to search these conclusions in a particular scenario. If you are having a new data with us and we want to predict the output of that particular data, in such a scenario it is very difficult to go through all the conclusions. In such a situation, we are using some machine learning algorithms to create shortcuts to reduce the search space. So here the importance of machine learning algorithm is there. Machine learning algorithms, what the machine learning algorithms do is it reduces the search space area, and it will easily find out what will be the conclusion or what will be the resultant. That is the generalization stage. So identifying conclusions or inferences from the abstract data is the generalization stage. So here we are having a particular example is there. We are having a large number of figures in our data set. Here you can see the reality. This is our data set, and we are having a machine understanding. In the machine we are provided a picture, and in this machine should understand that if two circles on the upper side and the line is there, then it will be says that the corresponding is a face. And if some rectangle or if any other figures occur in this particular area and this area, it will be recognized as the corresponding figure is not a face. If a figure with two circles on the top left and right corners and a line in the bottom part, the machine should understand that it is a face. If any other figures other than the circle appears, it will recognize that it is not face. This is the example for a generalization stage. And the last stage in the machine learning is evaluation. Evaluation means it provides a feedback mechanism to measure the utility of learned knowledge and inform potential improvements. That is, evaluating or measuring the learner's success and use this information to inform additional training if needed. So actually, this is the evaluation of our generalized data. It provides a feedback mechanism whether our abstraction is correct or whether our conclusion is correct or not. It is used to measure the utility of learned knowledge and inform any if any improvements are needed, that should be informed correctly. So to evaluate or measure the learner's success and use this information to inform additional training if needed. Model fails to perfectly generalize due to the problem of noise, unexplained or unexplainable variations in data like error due to sensors, issues with human subjects, data quality problems like missing values, null value, truncated value, incorrectly coded value or corrupted values. So in the evaluation stage, it can be the model can be identified whether any noise is there, if any error occur, what should be the problem for that particular error, is there any data quality problem like any data is missed or null values or truncated. All these things can be identified in the evaluation stage, or this will be considered. Overfitting is a particular scenario in machine learning models. The idea is that we are trying to fix the noise data in machine learning model. That is overfitting. The scenario is noise data means these are some unwanted data, and for a particular data set, some data are like that. Sometimes the data is missing, sometimes the data is having an unvalid, not a valid data, something like that. The problem is that in machine learning, if a model trying to fix that type of noise data, then that concept is termed as, or that scenario is termed as overfitting. Solution to the problem of overfitting are specific to particular machine learning approaches. So these are the 4 stages in the learning process. How do machines learn? In case of machine learning, we are having 4 stages: data storage, abstraction, generalization, and finally evaluation. Hope you understood the 4 stages in machine learning. Data storage stage, that is observed data are stored in the memory. Then the second stage is abstraction. We are having some data and this data should be converted to a meaningful form, which is known as abstraction. This abstracted data can be represented in the form of equation or in form of a graph or a tree, like that. The third stage is generalization. So the abstract data should be converted to a valid inference or a conclusion, that is generalization stage, which will be used for future references. And finally, we are having the evaluation stage for evaluating the final model. Hope you understood all these different stages. Thank you.